Hey guys, I just wanted to post a video about how to do one of these limiting reactant problems, as they will show up on your test as a long answer problem. So I just want you guys to have something to refer to as you go through some practice problems. I will post a link that has some great problems with answers that you guys can try, and hopefully this tutorial will help you get through them. So here's a typical question. Take the reaction of NH3 plus O2 yields NO plus H2O. In an experiment, 3.25 grams of NH3 are allowed to react with 3.50 grams of O2. Which reactant is the limiting reagent? So what we need to do here is figure out which of the reagents, now remember that these are your reagents, okay? Which of those two is going to limit how much product we can make? Then we're going to figure out for part B how much of that product we can make based on the limiting reactant. And then lastly, find out how much of the excess reactant is left over. So when approaching any stoichiometry problem, you need to first make sure you balance your equation. This equation is not balanced. So you can pause the video now and take a minute to try to balance that if you like. Once you've done that, you should get that you have a 4 in front of the NH3, a 5 in front of the O2. It's a wonky 5, but it is a 5. And then a 4 in front of the NO, and a 6 in front of the H2O. Okay, so there's your stoichiometric ratios. So to start, we'll start with part A. Which reactant is the limiting reactant? So here's our equation on the right here, scribbled in there. So what we're going to do is test both reactants for limiting. Okay, so we'll test this one and see which one might limit. To do that, we use what they've given us. So they've given us grams of each. Okay, that's how you know this is a limiting reactant problem, because they've given you grams of two things that are reactants. That's how we know we have to check for a limiting reagent. If they just give you one type of grams or one reagent's grams, and you're assuming that's the limiting, and you can just go forward with the stoichiometry. So let's test both of these. I'll show you guys how to set them up and let you guys do the math. But essentially, here we need to go from grams of reactant, so I'll put sub R, to moles of reactant. Then we need to transition using the mole ratio to moles of product. And then we're going to compare for the least amount of moles of product. So we're going to do that by using, this transition is done by using the molar mass from the periodic table. This transition is done by using the molar ratio. So let's take a look at that. I'm going to start with the NH3. So I have 3.25 grams of NH3. And again, I encourage you to write what grams and grams of what. I want grams of NH3 to go away, so I'm going to throw it in the bottom. And I'm going to convert that to moles. So I'm at this step right here. And there'll be some number of grams from the periodic table will give me 1 mole of NH3. Please, please, please always just put 1 mole per so many grams. Do not put any other number. It will be wrong. So now I want moles. I'm in moles of NH3. So I'm going to say from my equation that every 4 moles of NH3, whoops, here we go. Every 4 moles of NH3 gives me whatever product we want to work with. I'm going to work with the NO. Gives me 4 moles of NO. Okay. You can choose which product you want to do. Just make sure that when you're comparing both reactants, you use the same product. That will give you moles of some product. So I'll say moles of NO. Okay, so you could do that math. So all you'd have to do is fill in a number here from the periodic table, and then you'll get some number of moles of NO. Now to compare the other one, we're going to go ahead and do the oxygen. So for oxygen, I'm giving 3.50 grams of oxygen. I'm going to convert that to moles. So there'll be some number from the periodic table. O2 is easy, I kind of have it memorized. So we're going to say 32, so that is 16 times 2 grams of O2. Give me 1 mole of O2. Remember, when you're doing the molar mass, it's always for 1 mole. Do not put any other number. Okay, so then I go to my equation, so I can make this transition here, going to moles of product. And I want to put moles of oxygen in the bottom, so it crosses out. And I'm going to compare to the same product as I did in the previous one, so that would be moles of NO. Then I use the stoichiometric coefficients. So for oxygen, the equation tells me 5. And then for NO, that gives me 4. Okay? So when you do that math, you'll get a number of moles of product. Okay? Then you're going to compare those two numbers and you're going to pick the lowest. Okay, so pick the lowest amount of product and that will give you your limiting reagent. Okay, so for this one, I'm pretty sure it's actually the oxygen. So that's how you would do A. So of course, you're just missing this number here. Put a number in there, solve, and you should get some number of moles. Let me just confirm. Okay, so the reaction that's limiting is O2. So if you do that math, O2 should give you the least amount of moles. For part B, in part B, you can do this two different ways. In part A, you've already figured out how many moles of NO you can make using your limiting reactant. Okay, you've already figured that out, so you could start there if you'd like and then just go to grams. Or if you feel more comfortable, you can start all the way back at the beginning at this point here. Okay, so let's do it that way for now. So again, I'm going to use my balanced equations. So there should be a 4 here, a 5 here, and a 4 with this guy, and a 6 with this guy, and there should be an arrow because there always is. Okay, how many grams of NO are formed? You have to use the limiting reagent. Okay, don't use your excess reagent. You'll get this answer wrong. So we're going to use this for now. We don't really care about this guy. We're just going to focus on the limiting reagent. So I start with my grams, 3.450 grams of O2. In this one, we're going to go from grams of reactant to moles of reactant to moles of product to grams of product. Okay, so in order to do that, first thing, you'll see a trend here, always going from grams to moles to begin with. Okay, so you're going to have 3.5 grams of O2. I need to get rid of that, so I'm going to put grams O2 in the bottom and 1 mole on top, always 1 mole. The grams there will be 32. Then, this is 1 mole of O2, so now I'm going to use my stoichiometric coefficients for my balanced equation up here in order to figure out for this many moles of O2, how many moles of product can be formed. My moles of O2 have to go down here because I want them to cross out. I'm going to have moles of the product of interest, which is NO, on top. Using my equation, I can see that this is 5 and this is 4, so that's moles. And now I'm kind of right here in this whole process, and I'm trying to go to grams of product, so I'm going to use the molar mass again from the periodic table, but this time for NO. So 1 mole of NO, because I want those to cross off, gives me some number of grams of NO, and that's where I will finish. So we'll put some number in there. Okay. So if you do that math, you'll end up with grams of NO because all of these other units, grams O2, moles O2, moles O2, moles NO, will all cross out, and you're left with grams of NO. Okay. And for this problem, the grams of NO should be 2.63 grams of NO. If you don't get that, then you should definitely see me sometime before your test or shoot me an email. So that's part B. The last part is, I think, the part that is the most cumbersome to you guys is finding out how much excess remains after. If we go back to the first page here, essentially what this part of the problem is asking is how many grams of the excess reagent are used or required. Okay, so if you didn't have to figure out if this was limiting or excess, you would already know how to do that. You've done problems like that before. So essentially, you're going to go ahead and put the limiting reagent into moles, because that's what we always do. Once these things are in moles, okay, so once these guys up here are in moles, you can use those moles to compare to product form or reactant needed, okay? So once they're in moles, you can compare anything from this equation. So once you're in moles, you can go from reactant to product, product to product, product to reactant, or reactant to reactant. You can compare any of those once you're in moles. Just don't do it in grams. You'll get in trouble. All right. So here we are. How much of the excess reactant remains after the reaction? So we know we have the original amount of excess here. This is our excess reagent. Okay. That's the original. So like any kind of subtraction word problem, we're going to say original minus used equals the leftovers. Okay, so that's what we're going for here. Original minus used equals the leftovers. So let me get this equation balanced again here. 4, 5, arrow, 4, and 4. Come on, 4 and 6. Okay. All right, here we go. So, as always, we are going to start with the limiting reactant because that is what tells us how far this reaction can go. So, 3.50 grams O2. And as you can probably predict at this point, we are going to put grams in the bottom and moles on the top. And it's going to be 1 mole because we're using the molar mass. Happens to be 32. Okay, so that gives us moles of O2. So what we're planning here is to go from grams of reactant, 1, to moles of reactant, 1, to moles of reactant, 2, to grams of reactant, 2. And that will be the grams that are used in this process. Okay, so far we've done this. Now we're moving on to moles of reactant 2. The way to do that is through the mole ratio from the stoichiometric coefficients from the balanced equation. Moles of oxygen have to go in the bottom because we need to get rid of them. And moles of the things we're trying to compare have to go in the top. In this case, it's the other reactant, which is NH3. The balanced equation tells me that for every 5 moles of this thing, I need 4 moles of this thing. That's what's required for this reaction to proceed. Then, to go, we're here now, we are going here. To do that, we are going to use the molar mass. 1 mole, always, of NH3 is going to be some number of grams of NH3. Okay? So, grams of O2 cross out, grams of O2 cross out, moles of O2 cross out, moles of O2 cross out, moles of NH3, moles of NH3, and I'm left with what I was looking for. And that will be grams used. So whatever this equals, this will equal some number. You're going to take the original, which is 3.25 grams, subtract this number, okay? And that will give you your leftovers, which should be that, okay? So, give this problem a shot solo. Make sure that you can get there. And if not, then you need to speak with me before your test. If you can get there, then take a shot at the other ones that are posted online. And I'll post another video about percent yield so you guys can have some practice with that as well. Hope this helps. Talk to you later. Bye.